Good morning, everyone. I'm Всеволод Rodionov. I'm working on some startup that is working in financial technologies, and I'm partially tech lead, partially product owner. So I care about the features. I care about what we can do. And once we thought about the new API for our users, so we thought maybe we can do some specific API in browsers that can be installed in every website. We thought, okay, we can just build a library. No, we need to keep some users' data. So user can log into any website. User can go to our API and get the data on any website. It's totally same. But it should work on. It should use client-side storage, not server-side storage. So we can use browser plugin, we thought. No, we cannot because we also need to support mobile browsers. We need to support mobile browsers, we need to support desktop browsers, and we had a big problem. We had a few hacks that were performed by browser plugins. So for example, Mega NZ plugin, which was a big plugin for file storage. It had over 1 million installs, active installs. It was hacked, and data of Facebook logins, data of Google logins were stolen. So we had to implement some kind of security that is protecting us from our fraud, from fraud from browser plugins, from fraud from our third-party integrations. So the problem, we need to implement a trusted platform. We just didn't need to just store the data. We need to implement some platforms that provide an API. So it should implement something like this. It should provide us. It should never give us sensitive data, the private keys. It should give the function to sign. It should provide some get keys function, so user can get our public keys. User can sign some data with private keys, and our API that is provided to our clients can verify the signature. It's external API that is not relying on our features. It should be offline. It should support user confirmations. It should support either browser and mobile, and it should provide a man-in-the-middle protection and everything. So we should really care about users because it's their data, it's financial data, it's their significant action that is verifying that they are actually want to do something, and we need to really be very careful. So what we can require? We can require something possible from our third party, like HTTPS or some specific headers. More is less, and less is more. So actually, we only need HTTPS from them to verify that they are secure too, nothing more. This should be working on any platform. We can require a modern platform, we can detect the user agent, but we cannot totally verify that this user agent is actually working. So, for example, Brave browser is mimicking under the Chrome browser. We have a ton of Chromium-based browsers and mobiles that have their own plugins installed, but we cannot install the plugin. So we can expect some, Chinese phone like Xiaomi that is working on their own platform, that is having their own browser that looks like Chrome, that quacks like Chrome, but it has its own browser plugins, and we cannot do nothing with it. So it can be hacked, but not us, and we cannot detect it. We need to build a security platform based on some core concepts, like standards of web browsing. The more fundamental, the better. The simplest implementation of the platform was something like this. So we have an iframe. So we are sending the data in iframe URL. It's parsed on client. So we are just looking at the location and do something. We didn't care about handle function actually for now because we're not talking about how to sign the data. We're talking about how to protect the connection. So the base concept was we're just loading with URL, we're having some interaction with local storage, and we are returning the data via post message. It's that simple and it's that unsecure. We have a ton of attacks. We have man-in-the-middle, we have plugin attacks, we have server-client attacks, everything. And this is our problems. We can lose our private keys. It's the most sensitive action. We can just get the denial of service. It's not so bad, but it's bad because just API is not working and user do not know why. It's just stopped working. We cannot detect all the cases, so we cannot throw error on every case because it's not always understandable. But in general, we're fine with not working sometimes because it's protecting our user. We can flood our user with notifications, so it's like a ton of spam in their notification area, so like tens, thousands, hundreds. And as the last thing, we can compromise our public data as long as both arguments of sign function and the signature are public for us. So it's going to the server, which is publishing it. We actually do not care, so it's thing to discuss in other places. I know the implementation, how to fix it, but it's not inside the core technology. So first of all, the very important disclaimer. Examples are written in pseudocode. Examples are more about how technology works, not how to make it work in real. Also, I'm not personally a real security operations. I can hardly name myself a front sec. So I worked on some attack investigation and worked some attack protections in a real big project, but nothing more. So several companies are performing the security audit of this technology now, but it's not finished yet. I cannot guarantee you that all of the components work in 100%. So there can be some vulnerabilities of several concepts. They can be fixed, maybe. I think they can be fixed if there are some vulnerabilities, but in general, if you want to know about the security audit progress, just contact me and messenger everywhere, and I'll keep you informed. So this is our base concept again. It's that vulnerable because if we're just setting HTML code, it can get a man-in-the-middle attack. We need to ensure we have a secure tunnel. It's just a beginning to prepare to understand how much security we really need. So first of all, we can get a DNS intrusion. We can use DNSSEC technology. It's more or less new. It started in 2010. It's providing the public key infrastructure that guarantees us that we are really getting the correct answer from DNS servers. To ensure the data transferred correctly, we can use HTTPS transfer. But we have a big problem. HTTPS is good, but if we're making a first initial connection, it's performed in HTTP. It's not secure. It can be hijacked. Any other data can be placed by any router. So we need to ensure that we'll get some HTTPS data first. We can use the strict transport security header to tell browsers that every next request should go to HTTPS, not HTTP. But we have to pass the first request anyway. So always the first request is HTTP. After that, HTTPS is fine, but first request is always unsecure. But we can use the technology named strict transport security preload list, HSTS preload list. It's a public list. It's included in every modern browser, like Chrome, like latest Firefox, like Edge. And browsers know that there is a list of domains that should always be loaded as HTTPS. They are bundled with public keys from the certificate chain. They are bundled with this information. So if we're loading this page, even if it's attacked by Chinese government, we'll always know that which certificate we should expect, and it's never loaded by HTTP. It's very similar to the technology that is used by mobile applications when they are having certificate bundled in their application. So they never rely on public infrastructure. They are relying on their own servers, on their own certificates. And the last thing, we should use the latest TLS because actually TLS, HTTPS is damn vulnerable. So this is a list of attacks that was performed on every year. It's like for the last few years, it's about 30 attacks on HTTPS for every year. So do you know some of them? I personally knew Houndbleed and Logjam. It's finding names of all attacks. So what should we do next? After we insert our iframe, we should check whether this iframe is valid or not, whether another script is not trying to mock it, that no one is attempting to change its source, its URL. So we should also use mutation observer. So we have untrusted iframe. We have, but also another thing we should consider is that we have non-secure tunnel. So anyone can read the messages from post message channel. Anyone can read from these messages. So we need to ensure somehow that it's not intrusive. So we can create a secure context that is non-injectable. It's called blob URL blob iframe. It's like we're creating a file in our browser. We're creating the URL for it. It's having a very specific origin. It cannot be injected, and we can place our original iframe inside this blob iframe. It looks like this. We're encrypting our data, and our blob iframe that cannot be injected, that is like a small secured context, is producing the data in encrypted view inside our top frame. So if it's decrypted, it's fine. If it's not decrypted, it's possibly hijacked or it's not our data, so let's just skip it. So we ensured we have a secure tunnel from this iframe, the bottom iframe, to the top. But we still cannot rely on our servers. We still cannot guarantee our users that in one day someone will just, okay, let's change the data on our servers and send the malicious script that will send their private keys to some other place. So we need something more. We need to check the hashes. We need to check the data that is launching. We need to verify that something is working correctly. We need to make fetch request first. We need to verify that data is placed inside the cache. And after that, we can say, okay, if we'll load this iframe, it has cache parameters. It's making us believe that it will be loaded from the cache, not from server. So we are checking all the iframes, all the headers. We're checking the integrity. It's equal to checking all the contents. After that, we can trust in our cache. So logic is something like that. First of all, we are fetching. If fetch is fine, then we are loading it as iframe. But we can go offline, and this is where interesting thing starts. We can use a service worker. It looks like this. So we have a registration in our core launcher. So we have a specific page that is initializing it. So we are prompting user if he doesn't have anything to, okay, open this page and install the service worker. It actually doesn't require anything from him. It's just like he opens the page and it's installed. We also need some APIs like notification API, like persistent storage API. It's all confirmed by user, but service worker itself is not confirmed by user. Its code is looking like this. So we are registering fetch handler. So it's like we are handling this fetch. We're handling it, and after that we are responding with some data. We cannot fetch it directly because cross-origin fetch is not possible, but when we're loading an iframe, it will initiate the fetch handler in service worker. So what is a service worker? When computers were big, the browsers were just going to server asking, hey, give me the data. But so it's just like browser making the fetch. But nowadays it's much more complicated because first of all, fetch is going to cache. Cache is checking whether he has data. Cache is checking whether he has a service worker for this origin. And if it does, if it has a fetch handler, and if fetch handler is producing the response with callback that is providing the response, then it's responding with this response instead of server. So it's a small loop. It's a very small loop that is just like it's going to its cache, it's launching the JS script in its page, and it's responding. So once again, we have a special script that is placed in the cache, that is placed inside our browser, that is installed. It's not going anywhere, even if our server is down. And if our server is down, if something is wrong, it's still responding with the data. Inside it, we have totally same script. It's having totally same logic. So now we have not only the secure tunnel, but we have a secure script that is executed in context of our origin, and it's running inside the user browser. So we're actually not interacting with our user, with our servers. We can more or less rely on browser behavior. But it's not all that we can do. We also need to check whether user is actually expecting to perform the signature. We need to check whether we can really, that user is actually expecting this behavior. So we need some notifications. We need to, sorry, wrong slide. We need to perform the notifications. We need to require user to make the interaction. We need to ask him whether he really wanted or not. So what is important here is that we are creating the notification request. We are creating the, we are passing the data. We are passing the require interaction true. That means that we will not be closed by just swiping. It's always requiring some action from user. We require some action, provide some actions. So yes or no. And after that, a notification appears on screen of a mobile device or desktop device. So if you're just like your iPhone or Android, you'll see a ton of notifications usually. Some of them can be created by your mobile phone. But the handler of this notification is also inside the service worker, because handler of it is it's not bound to some specific page. Moreover, we can spawn this notification even without any of the pages. We can close all the pages and it will be still running, so we need some specific place that is handling the events from this origin. We need to handle the notification click event, and inside this notification click we can do something with the data we passed. So the next problem is that we have a code that is performing only inside the service worker. We have a code that provides us a confirmation, a continuation of actions, and after that we need to respond to user. So we're doing something like this. But we still have a problem. So, okay, we created a response inside the service worker. We worked with our storage. We created a signature. We asked user for confirmation. But we have a extremely big problem with browser plugins. I didn't touch it yet. First of all, they can inject in every part of our communication. So they can intercept the fetch request, they can intercept the respond request, so they can read mostly everything. For big requests, they're performing a ton of actions. So like it's the actual flow of events in plugins. But for service workers, for data requests, for data URI, etc., we have only two requests. It's on before request and on response started. We cannot prevent it from capture, so all we can do is just simply prevent everything from appearing. So they can redirect requests, but they cannot change the data. They can read it. They can read everything that we're sending, that we're receiving, but they cannot simply change it. They can only change the headers. So if we're providing a domain that is not simply creating an iframes, that is not spawning any frame, they can do nothing with it. We need to do one small trick. We need to create no frames. So that means that no page in our origin will be spawned. We cannot simply do this. We can either redirect user to other domain, or we can create something special. Like we created the blob URL, we can create data URL because, so we have data URL, we have blob URL, we have file and home extension URL. If we're creating iframe with sandbox without allow same origin, we're also getting origin null. That means that local storage will not be available, that nothing will be available. It will be like empty page, but with content. So we need to create some very special URL and redirect to it. We can do something like this. So what we're doing here, it's the core thing from this talk, actually. All before was a big introduction. So what's happening here? We created our iframe. Our iframe performed some actions from user using our local storage. We got the confirmation, we got the signature. After that, we are creating the special URL with our signature, with the execution result. We're creating this URL, it's like we're creating the simple HTML page, and we are redirecting user to this page. Inside the data URI, it's totally correct URI. It has origin null, and it's simply redirecting user to this origin. So any request that comes to our server is just get away, get away, get away, get away. And it prevents our browser from spawning any page in our origin. So nothing can actually inject in it. Neither browser, neither third-party scripts. It's only service worker that is running in our domain, in our origin. And so this is how actually the core technology works. So it's looking that simple, but it takes a lot of time for me to discover it. So what else can we do? We can use WebSocket connection that is uninterceptable. It cannot be redirected. It can be read because no one can actually read the service worker. No one can actually read the WebSocket because plugins are not able to perform this. We can sing out a lot of things. So we can create a secure tunnel that is sending our signature to some remote server. Via this, we can actually create a lot of stuff. But the core thing is that if we're not spawning anything with our origin, we are more or less protected. So the core result is that our user verifies our actions. The third-party scripts verifies our server. Our server verifies that everything is fine. We will offline friendly. So if our server is down or hijacked, we are just shutting it down, and it's still working because service worker is working in browser, not on our side. And we have more or less secure channel. So what's not implemented in this description, it's like a much bigger talk for a few hours maybe. It's about how to import scripts, how to configure it, how to ensure the secure communication, how to do a lot of stuff. It's integrated process. It's not like you implemented something and you stopped. It's like you're thinking out how you can be hacked. For me, I have a special plugin that was crafted for me that was attempting to hack me on every page, and if it succeeds, he's just showing me, hey, I hacked you, and that's how I actually work. Security is a big process. Security is something important, and for us, for our browsers, we didn't actually care about it sometimes because we thought that browsers are for data, not for something secure. So we're just changing the articles, we're sending the links for each other, but we don't actually think that in our browser we have something very secure, like our messaging, our photos, our bank accounts, and our medical data. So if you're really working with it, just be paranoid, okay?
Thank you. Any questions? Shall we switch to Russian or we can...
Я думаю, по-русски лучше.
Окей. Вопросы какие-то есть? А у меня вопрос, я вот юзер, да, если я не программист, как мне, я параноик, как мне защититься самому? Можно ли сделать плагин, который будет это оборачивать все?
Можно просто выключить JavaScript, мне кажется.
И тогда весь интернет просто отключается.
Ну, кстати, половина работает.
Так, вопрос. Еще вопросы?
Скажите, пожалуйста, Александр, скажите, пожалуйста, а для каких целей использовали когда-либо сервис-воркеры, какие кейсы?
Ну, кроме банков.
Да. Ну,
На самом деле для умного кэша очень удобно использовать. Опять же, если есть какие-то уведомления, то это единственный способ работать с ними. Ну, там просто фундаментально. У меня не очень типичное использование для сервис-воркера. У меня в нем поднимается канал сообщения. Он еще предоставляет помимо обработки фича, обработки notification клика, еще месседж. Через него можно общаться между вкладками. Это самый удобный способ. Потому что у меня в нем появляется какая-то дополнительная логика, которая там пришел запрос, он агрегировался и отдает новое состояние. Но вообще его обычно используют просто для кэша.
А чем умный кэш, чем кэш браузера не угодил?
Во-первых, он недоверенный. Во-вторых, когда мы загружаем просто из кэша данные, то мы не знаем, что нам пригодится еще, а тут можно, допустим, загрузилась страница, мы знаем из...
Префетч.
Не совсем префетч, скорее, не просто префетч, точнее умный префетч. Я видел наработки по тому, что у нас загружается страница. После этого в фоне начинает загружаться статистика по использованию вообще страниц, предиктивная. После этого начинают подгружаться данные для следующих страниц. Пользователь кликает, а это уже в кэше. Это простой пример. То есть это действительно какой-то промежуточный сервер, который умеет подгружать заранее данные, который умеет как-то с ними работать, необходимость удалять. Например, простой пример есть. У него есть один из стандартных режимов. Когда запрашиваются данные, он отдает то, что лежит в кэше, после этого начинает заранее загружать следующее. Это актуально для каких-то данных, которые достаточно быстро устаревают, но при этом хотелось бы отдавать их побыстрее.
Спасибо. Еще вопросы? Тогда я продолжу с вопросами. У нас просто тематика предыдущего доклада и следующего – это статический анализ кода. Да, собственно, вопрос, есть ли, как вы думаете, можно ли применить ваш подход, да, для анализа кода чужого, предлагать, собственно, делать какие-то обертки и так далее?
Это не про статический анализ кода, это скорее про демилитаризованные зоны. То есть у нас выделяется отдельный контур безопасности, в котором есть какие-то известные вызовы функций, и ничего неизвестного туда не попадает. То есть, допустим, вот тот же самый, то, что я называл handler.js, который выполняет сам функционал, он в моем случае вообще состоит из другого языка и интерпретатора к нему, который просто не дает выходить в какие-то API. Там ему предоставляется сеть, ему предоставляется уведомление, ему предоставляется криптография. Ну и хранилище. Соответственно, все, что он может, это либо подписывать, либо отправлять куда-то удаленно.
Спасибо. А у вас, опять же, да, если вопросы, я продолжу. Вопрос у меня на самом деле такой, что вот вы написали, да, это применили в каком-то своем продукте.
Да, ну,
это как библиотека у вас, которую вы используете в своих продуктах?
Нет, это вообще на самом деле мой...
Или approach просто?
Это мой, на самом деле, личный проект, который просто сейчас внедряется в основной продукт. Ну, так просто вышло случайно. Просто совпали потребности в какой-то момент. Это не совсем библиотека, потому что она требует настроек на всех уровнях. Это не только код, но это еще там настройки DNS, это настройки веб-сервера, которые отдельно запускаются. Ну, то есть заголовочный файл — это, естественно, отправка через код, но это не только JS. Поэтому это не идет как библиотека, это идет именно как отдельный домен, который предоставляет набор разных решений.
Спасибо.
Вот я не знаю, как объяснить точнее, к сожалению. Все. Настолько достал, что прям стоп?
Нет, у нас есть еще, конечно, много минут в кулуарах и здесь, пока не начался.
Я надеюсь, что было не очень тяжело, что что-то интересное было, если честно. Очень надеюсь.
Спасибо большое.